All right. Our last one on this sheet is kind of the AP test restricts you using the calculator for this one in most cases, so you have to show work. But this is something you can kind of check with. You have to kind of back it up with a little bit of work or some type of explanation if you do this. We want to find the x values that minimize, or maximize a function. Well, if we look at the derivative of the function, kind of the same thing we just did, let's look at this graph. So I'm going to go back to y equals and clear these out. This time our function is 0.1x cubed plus 5 log of x squared minus x squared plus 4. But we don't even want to use and look at this graph. I'm going to go over to the equal sign and hit enter. And what that does is that equal sign is no longer highlighted. I'm not even going to look at that graph. What I want to look at is the graph of that, the derivative of that. So we're doing kind of what we just did. We're going to do math 8. We're going to do the derivative in terms of x of this whole thing. So y sub 1, I'm going to do vars, y vars, and y sub 1. And we're doing that in terms of x. So now with that equal sign up here, it's no longer highlighted. All I'm looking at is the derivative of that graph. Eventually. Alright, so this is our graph here. I guess we've got it down here already, but we'll just use these. If we were trying to find the values where x is greater than 1 that minimize this function, well, greater than 1, if we're looking, we have, remember this is the graph of the derivative, we have 2 zeros here. So this 0, we can find that like we talked about in the first technique. We'd get 1.709 approximately, and this one is at 6.302. Well, this is the derivative, so right here the derivative is positive, over here the derivative is positive, and down here the derivative is negative. So you may want to write it like this, because we're a little bit more accustomed to looking at it on a number line, but right here at 1.709 the derivative is 0. At 6.302, the derivative is 0. And then it's positive to the left, negative in between, and positive. So what kind of a point do we have here? Changes from positive slope to a negative slope, local max. Right here, local minimum. Well, we'd have to check this and 1 to really see what our our absolute minimum is. But this allows us to find those critical values. One